for the pre-stressed concrete composite girder bridge. And when I say pre-stressed concrete composite girder bridge, I mean that, including the precast girder and also the post-tension girders. Post-tension box girders for segmental bridge applications, that's something that we've always had since 2 years ago, 3 years ago. But we nearly developed the pre-stressed concrete composite girder bridge as per ASTO this year. So for the composite girder, either precast or splice girder, design checking and rating is what I'm going to focus on today. And before I move on, just wanted to, since this training is for the users only, I wanted to share something for users first. Right now, actually this Saturday, 2 days after, it's the 5th anniversary of Midas in the New York office. So we are having 2 events. The first one, everyone can try. You can actually, I believe a lot of you guys already answered these questions, but you can actually take the survey and receive a $5 Starbucks gift card. The questions are pretty technical, but it's for our current Midas users, the current like the managers and the IT steps and the purchasing steps that are related to the Midas civil license at your office only. So if you're the user or if your office has the license, but you haven't had a chance to receive this information yet, feel free to let me know. You can see my contact information below over here, or feel free to just email back to our general mail. But yep, so that's about the first one. Second one, we are also having software and service offers. Again, this is only for our existing users. We are providing a lot of benefit for any purchase that you want to do within this time duration as a way to kind of give back to our clients. Now getting into the training itself. So what is the composite girder module, and what I am going to focus on today among the features related to this module. So basically for a either steel or pre-stressed concrete composite girder bridge, we have different modeling approaches. The wizard, but one of it is by modeling using the wizard. So basically, using the wizard, you can model steel plate girder or pre-stressed concrete composite girder bridges. And also, what I want to go over today, and something that's been requested many times in the previous training, is how do you make flexible modifications once you use the wizard? So basically, a lot of our users right now are familiar with, the composite girder bridge wizard. However, I think it's not something very widely known how to change the wizard information or how to redo the wizard that you already created. And also, how do you make modifications in the model that you already created using the wizard? Or yeah, so I'm going to go over that today also, before getting into the actual design and rating part. And also after this, I'm going to walk you through the new design and rating part, the pre-stressed concrete composite girder bridge, design checking and the rating. So the bold lettered ones are going to bold letters topics are what I'm going to focus on. And before getting into the whole scope of it, I first wanted to point out that you are able to do both the line girder approach and also the system model approach. What I mean by line girder model is, if the structure is very simple, straight, simple, or even if it's continuous, if it's straight, and you would rather just take the simpler approach than modeling the entire system, you can go for the line girder model analysis, design, and rating check. The best modeling approach for this is by manually modeling using node and element functions or the text and table input. The benefit of doing this line girder model is that, of course, it's very simple. And also, but then it's very simple, but it's still an FEA program, finite element analysis software, that you're able to get accurate analysis results. And also, so that's the main benefit, how easy and fast it is. Downside of this is that, you're not working with the entire system, so that, it can be more conservative or a little less accurate. However, since, we are doing the line girder approach based on what's already established by AASHTO, feel confident to go with the line girder model too if you prefer the simpler approach and have the proper condition for doing the line girder model. The second way is to do the system model analysis, design, and rating checking. The best modeling approach for the entire system study is by using the wizard. The second alternative that I suggest is by manually modeling or using the CAD import. And for both the line girder approach and the system girder approach, you are going to do the design, rating, checking, analysis the same way for either approaches. So the only variable here is modeling. And then how you can determine it is based on the structure condition and so on. And I'm going to briefly walk you through how you can do the line girder model. However, since this is a user training and I'm not going to spend too much time on it, if you are really new to midas, need a guidance on how do you, for the manual modeling for the line girder approach, I can suggest a good training material so that you can learn about this on your own. But it's very simple. And I will share about that manual after the training in the follow-up email. I'll be guiding you to a specific training manual. So the wizard I mentioned. So before getting into the actual design and rating, remember I mentioned that I'm going to show around how you can manipulate, fix the wizard data or the model that you already created using the wizard. Give me 1 second until I change my screen and get to the program. And after going through the wizard modification, I'm going to come back, walk you through the design input and also the new, like the changes in our design as the precast and the splice girder design checking and rating checking joined. What are the additional checking parameters implemented and so on. So I'll be going over that also. So let's go over the wizard modification first. Okay, so basically, this is a completed model using the wizard and also by modifying some of the information that are created by the wizard already. So to kind of give you an overview of what happened to make this entire structure, remember I've already done a training to go over the modeling part. It's the first session that was done about a few weeks ago. If you want to learn more about the wizard modeling, it's done already. We can guide you to the past training. So today I'm going to focus on how do you make modifications and how do you add an additional information after using the wizard. So basically this structure was created by using the wizard, right? And then right now this completed structure, it's actually a completed status. And if you were to, if you wanted to make modifications, you have 2 different ways. One, let's say you're at a very preliminary stage. let's say you completed modeling using the wizard. However, you're not too far after the wizard that you just want to make the modifications using the wizard. That's number one, right? So in that case, how do we do? The first way is, I'm assuming that you all already know that you can save the wizard data by using the save function in midas. So basically in the wizard, you can save the information that are put into the wizard by using the save as function over here, right? Let's say I've done it already. What I can do if you want to make modifications in the wizard is, number one, you can start in a blank new model. And then here, how you can do it easily is by just going to the wizard again, right? And then once you're in the wizard, you need some of the properties like material and section. In the previous example, in the previous wizard, when you created the wizard already, you probably have your material and section defined already also. So what you can do here is, right now we don't have any data, right? But if you want to make modifications to the wizard data that you have already, what you can do is first import the property. So basically go to the property window and find the exact model that you want to import the properties that are defined in the specific model, right? And then midas will be able to bring a list of the materials or the section, depending on where you do. And you can actually make selections on which property you want to import. Say OK. And then you can also move on to the section. Specify, select which section from here you would like to bring it to the new wizard data. And once you do this, right, we now have the base properties, material and section. So now what we can do is go to open and then find the wizard that you have already created, right? So by doing this, what just happened is, instead of re-inputting the wizard, I just brought the data that's been saved in the other model. And same for the wizard. I was able to open and bring back the data that I have previously saved. And here, the main point of doing this was to be able to make modifications, right? So if you want to make modifications here, just go ahead. If you want to make modifications on the properties that you have already defined, you can make modifications, right? Once you open them, choose a different information and say, OK, it's going to change that information. Same goes for the section. Let's say it turned out that you need a different size girder. Just go ahead and pick a different girder, save it. And over here, if it happens to be that you need one less girder, just modify the information here, right? And once you are done making the modifications, you can again save as the wizard data and do it, right? And over here, let's say I before, remember in this model, I had a two-span model. But let's say, we are only dealing with a simple span structure. So I'm going to show that modification. And here I changed the span information from 2 spans to 1 span by getting rid of the span length of the second one. And then I'm going to save it as 1 span wizard. So this wizard data has been newly saved. And once you do this, you can just go ahead again, say OK, and create the data based on the new wizard data. So that's how you can make modifications. And number two way, right? So if you already work with the wizard, and if you kind of want to undo what happened before, what you can also do is you can also say undo here. So after making modifications, you can come back to the wizard and redo the data. Or if you want, you can do the undo button so that you can undo the wizard, come back to the wizard, and do it again. And then another way will be, so if you have the data like this, and if you want to make modifications here, what you can do is just in the complete model by the wizard, right? In the model that's been created by the wizard, you can actually make modifications in this model. So, but then the modifications that you can do it this way will be, they have, the type of modifications that you can make this way is a little bit different from the modifications you can do using the wizard. Using the wizard, you know, it's going to be more like getting rid of one girder or adding another girder or changing the bridge overall parameter, right? But then the modifications that you want to make after the wizard are more like, let's say I need to add an additional loading information, right? Right now in the wizard, there's no temperature loading input, right? But then let's assume that we also need to consider the temperature loading. So what I'm going to do is, what you can do is, you can go to the specific main menu for that specific function you need. You can create a new loading case. And then after you create your new loading case, I'm not going to do it since I don't want to lose my analysis data, but you can always add a new loading case. And also once you add the new loading case, you can go to the specific loading you need and specify the loading data information. So here you can choose the new loading case that you've defined and also the loading group and define the new load. So all these functions, right, the load main menu, boundary main menu, or the property, they are all open for you to make modifications after. And also if you need to modify the data that's been defined using the wizard already, what you can do is from here, let's say you want to make modifications to the wet concrete loading, right? You have two different options, actually many, but then I'm going to walk you through two different options. One, you can actually utilize the function that's, you know, like the basic function in the wizard. So let's say if you look at my loading data over here, for the wet concrete, I have element beam loads, right? In case you cannot see very well, the type of the loading that I use is the element beam load, right? Then what you can do is you can actually go to the element beam load function using the main menu, and you can actually search for the exact link that you need to make the modification. So here we go, wet concrete. Wet concrete is in the group DC12. And then if you want to make modifications, choose an option called replace and enter the new number that you want to exchange with the current value, and then select the elements that you need to apply the loading, right? The girder, main girder. Let me make the view clear so it's easier for you to recognize. So I only selected the girder elements, right? And then you can apply or change the loading value this way. Or if it is, we already have a certain loading value, but the problem is to add a little more or take out a little more. You can either use replace, or if it works out by adding additional value, you can also edit, right? So this is one way, by using the main functions in the program itself. And the second way will be fixing the data in the tabular format. So midas, it's a very graphical tool. you can see everything graphically, but it doesn't mean that you can have the data in table, you know. All the basics we do. So if you want to make modifications, you can also get an access to it by the tabular format. So here, what we are seeing right now is the beam load table. And here, if you see, the data is organized by the loading case. So starting from the wearing to the wet concrete and so on, you can have the loading data in the tabular format. And if you want to make modifications, you have two options about the table format. You can either edit directly in the table, right, just by punching in, or if you want, you can just copy this data, bring it to the Excel, paste it, and then, you know, you can use your replace or like whatever it is to change the data. And then after that, you can actually copy paste. You can copy paste it back into midas civil, so that you can, if you are more expert in Excel, which we kind of all are, you can use make easier modifications using the wizard too. So those are the two different ways. So after using the wizard, two ways, you can make the modification by redoing the wizard, or number two, by you know, just using the main menus in the program itself to add an additional information or change the information that's defined by the wizard. So that's what I wanted to cover before getting into the actual design and rating portion. Okay. Yep, coming back to the design. Okay. So we already had the design and rating as per AASHTO for the concrete beam, right? However, what we additionally added is the design and rating check for the composite pre-stressed girder girders. So we have the same thing about the strength limit state and the serviceability limit state and the rating. You can see like an overview of the checking parameters about the flexural, shear, torsion for the strength, serviceability. You can actually check the stress for the cross-section at the construction stage or at service loads, and tensile stress for pre-stressing tendons, principal stress at construction stages or the service loads, and also you can check crack. And couple additional checking parameters that are added because, you know, we only had the box girder, non-composite, and then now we do have the composite girder. The crack moment calculation has been modified according for the composite sections. For the composite sections, this equation 116 as per AASHTO 57332 is newly added to compute the unfactored dead moment for the non-composite section, the composite section. And the calculation for the SNC is also newly added. So crack moment checking and also interface shear. So interface shear between the deck and the girder for the composite section also needs to be checked. This is something that we didn't have back when we had the non-composite girder only. So this is also added. And for the torsion checking, the way we calculate, like the area for the torsion has been also updated as per, for the composite girder sections. For the design checking, you can actually, I want to point on a couple of design inputs. So you can modify your design materials. So basically, when you define your material, you choose the database, right? Midas will be able to bring the material strength according to the database that you selected. Checking your, selecting your material for the checking and the material strength. And also another design input that I mentioned before, For the interface shear checking, you can actually check what is the surface classification as per S25843. Please note that whenever you use the program, you'll be able to see what part of the code it's referring to in the interface itself. If not, you can always find them in the online help manual or the design guide manuals. You can choose the parameters for the surface classification. Either it is rough cast in place or monolithic or intentionally roughen and so on. You can choose it according to the code. And for the result, you can actually get to the result table for different type of different categories. And for the result, there are tabular type like this, and also there is the report format. Table is pretty simple to extract. I'm going to go over how you can define your design inputs and also the rating inputs and getting the Excel report. For the load rating, the important parts are specifying the rating parameter and also the bridge rating group. So bridge rating group is important when you reflect the condition factor. For different group that you have, you can specify different condition factors. And also defining the rating case. In midas, you can define the rating cases for each vehicle you have, meaning either design vehicle or the permit trucks or the special permit trucks, whatever the case it is. If you defined it in the moving load analysis and ran the analysis for them, you can actually define the rating case for each vehicle. So that's also what I'm going to touch upon. And you can also get the rating result in the tabular format like this for each different limit state, and also in the Excel format like this. And when I get into the design, I first want to walk it through just giving you an overview about the line girder approach. So basically how you will model the line girder really briefly, and just moving on to the design and rating part. And then as the main part, I want to cover how you can input the design, input and the load rating in the complete system model. If you have a line girder model, it's actually very simple how you model this. Basically, you can start by manually adding nodes and elements, and also the properties, material, and the section. And also you can start, so you first need to model the nodes and elements, very simple. And how do you define your section or material? You can define them in the properties and assign them using when you define your node and element, or when you just have the things ready in the tree menu, you can simply drag and drop in order to make changes with the properties or anything else. And once you do, you can also move on to the boundary. You can define your support. For the line girder, you can take the 2D approach also. You can define your support manually, and also you can define your loading cases manually. Very simple. And for this manual modeling approach, we already have a lot of tutorial manuals ready. So if you need to know about this approach, please pay attention to the follow-up email that we'll be sending out to you after the training. Okay. And regarding the material, one of the questions that was raised is, so basically in midas, there are two ways to reflect the long-term property of concrete. For steel plate girder composite structure, you have two ways, either by defining the modular ratio, 3N method, or by defining the creep and shrinkage functions or the compressive strength function for your concrete. But for steel plate girder, 3N approach is more general. That's also covered in the previous training. But today, since we are covering the pre-stressed concrete composite, the approach that we need to take in order to reflect the long-term effect of concrete is by defining the creep shrinkage function. So basically, in addition to just simply defining the material out of the database, you need to pay attention to a couple more things for pre-stressed concrete composite with bridge. So basically, you have to pay attention to creep and shrinkage for the long-term property conditions. So you will have to define your long-term creep shrinkage condition. In midas, it's very simple. No need to define like functions or graphs. You don't need to do it. We have the database according to CBFIP and ACI and so on that you can just simply define the parameters required to compute the function according to CBFIP or ACI. So defining your creep and shrinkage and also defining your compressive strength is what you want to do in order to reflect the long-term effect in pre-stressed concrete composite bridges. However, since this is a training geared toward more for the design checking, let me now get to the design and rating part. So here, once you are done with modeling, right, you can now move on to the results. Why results? You can review your results using the functions like the graph or diagram or the tables. But important thing that we need to do here is specifying the load combination. So in order to perform, in order to do the design checking as per AASHTO, we have to specify the load rating, the load combinations. And in midas, you can actually define them automatically using the built-in, like the load combination database. So basically, when you go to the results, load combinations, you need to go to the concrete design and create your load combinations according to AASHTO. And here, in order to reflect, any like reduction and things, you can actually reflect that in the load modifier factor over here for your design checking. And also, feel free to take a look at the other parts. And so this is how I was able to create all this very nicely described loading cases. Once you do, the program will produce the loading cases according to AASHTO. And once you are done reviewing your results, right? Not going to mention that in detail since it's already covered in the previous training too. You can move on to the design and the rating. Actually, for the pre-stressed concrete design, you can find it under the tab called PSC, standing for pre-stressed concrete, right? And here, you can first start by selecting your code, AASHTO LRFC12, specify the parameters for the design checking. The input parameters are, as shown over here, and details about these information, right? You can actually refer to the user guide manual for, like the details that that you can actually read through and have specific information about them. So like shown over here, right? It's actually going to walk you through the inputs related to the design and the related analysis output. And for this too, if you need further descriptions, please refer to the design guide manual. It will be uploaded in the web page, the review page that we are going to send after the session. So you can specify the tendon type and also exposure factor for the crack width, output parameters, corrosive condition, flexural design, the construction type, segmental, non-segmental, and also factored loads. So after you make, specify the design parameters according to AASHTO. And then you can also define the design material. So this is where you can choose the database, the material database, or if you need to make modifications to the strength, if your DOT has something special, not very general in AASHTO, you can always make modifications by changing, resetting your database here, and being able to have an access to modify the strength information of the material. And you can also specify the design position and output position. This is something a little unique in midas. So because midas is a finite element analysis software that is capable of checking the design and rating, you need to specify the design position. So basically, by specifying the design position, you are letting the program know about which element you would like to do the design, the corresponding design checking. And corresponding members will be the elements that have the girder section. It's the elements the girder sections are applied to. So these are the elements that represent the girder. And this design checking is for the girder members. So we are going to choose all of the girder elements and specify about the I and J node of the element, right? The beginning node and the end node of the element. We want to check the design. So that is what's about the position for design. And then the output for the design is something also unique. So remember I mentioned to you that you are able to get the Excel report about the design checking results right over here. And this is for that. So in order for the program to produce the Excel report, which is quite detailed as shown over here, in order for the program to produce these type of pages long design checking result report, the program takes about a minute or 2 minutes per output location you specify. Which means, right, some of the technical questions that we very often get is, when you're running the Excel report, it's taking forever or it's not being produced. It's one of the very frequently asked questions. The thing is, the Excel report for each location, it takes about a minute or so. If you decided to choose every single girder element and assign them as the output position, the program will need to take a long time in order to produce the Excel report pages for each location. So what we recommend is, this is also a frequently asked question by users. What we recommend is you first check your analysis output, or you first check your design result table in order to find out which locations are the critical checking points. For example, if you were to check like the bending diagram, you can go to the results. You can compare the analysis output, right, about each loading case or envelope of load combinations. You can actually see which location is the critical checking point. For example, right here, it's indicating that element 140 has the maximum positive moment. So when I choose this element and activate this element, you can see that element 140, right, over here, has the maximum moment, and you can also check it with the number displayed on the screen itself. So this way you can find out which elements are the critical elements that you want to review, right? So that when you review your Excel report, you don't need to review, not only that, it's impossible to review. It takes a long time to create Excel report for all, but also because it can save you a lot of time by being able to kind of point out, okay, which locations are the ones I need to review more carefully about. So that's something unique to midas, so that you can take up the design report like this for the location that you want to review. And then this is actually for the post-tension bridges. The segmental bridges. If the structure is a segmental bridge, you have to define your segment assignment. But now that's not the case, since it's not the segmental structure. And you could also specify which load combinations are the ones for different category check. So here, these are the load combinations that are created using the automatic load combination generation. Remember, over here, we created, under the results, the load combination, we created multiple load combinations, right? And these need to be categorized for different limit state check. So, this you can do it manually, but also if you create your load combination automatically, the program will be able to take care of this on its own. So specifying which load combination belongs to which limit state category check is what you need to define over here, right? And also defining your interface shear for this, you can specify, surface classification. For this example, this was the slab was casted in place, so I'm choosing this cast in place slab option. And then you can also specify the inputs that are required for calculating the interface shear. You can refer to our design guide manual for it, or you can actually see that this is for the AASHTO Article 5843. So if you need to find out what exactly this is, you can actually go to the code and find out which specific article that the checking is for. So you can actually come to the specific part and review what are the inputs that are needed in midas. And then after you are done, then you can perform design. You can check their result tables and then also review the Excel. For the sake of time, I have previously ran the design, so I'm going to share this Excel report with you. And also, these reports will be available online after the training. I'm going to post them on the review page. So if you want to download it and actually take a look, take a look. Even if you're not doing the design checking using midas, it will be a very nice guidance for just for the manual checking also. So basically, in the Excel report, it's going to present both the design input and output all together. So here you see, starting from the design condition summary, properties, materials, you are going to see all the design inputs, put in together nicely. And then after you're going through the design input, it's going to go through different checkings. And for, so according to AASHTO, it's going to take each step for checking it, and also it will give you the intermediate checking results. So this is the type of the output you'll be able to review. Also, another frequently asked questions are, can these number, is the formula, the function, like the equations built in? Equations are built in the database programming sheet, but they're not exactly in the report. report is a final product that the program produces. So in this Excel report, the equations are not there. The equations are there in the programming spreadsheet in midas, the installation file. But basically, this is the idea. If you want to see more details, these will be uploaded in the review page. So feel free to access to them and take a look. And for the rating, I mentioned to you, ratings kind of simple too. So here you can come into the bridge rating parameter input part, right? Here you can define the system factor. Remember, like the load modification factor is in the load combination, right? And in the rating itself, you can start by defining the system factor. This will be applied to the entire rating checking points, system factor. And here you can actually specify which limit state you want to check the rating for. Strength limit state, shear, is it segmental non, you can choose those things. And also for the service limit state, for the design loading, what is the stress limit, right? And what is the limit for the slab in case this is the checking for the composite section. If it's only the segmental, don't worry about the rest. If it's the segmental, you need to provide a slab information. And also for the legal permit vehicle, what is the stress limit for the girder for the service limit state check? And what is the stress limit for the concrete deck portion? So you specify those information in the rating parameter, right? And also, would you like to how would you like to get the load test measurement? By strain or by displacement? Those things you can also specify in the rating parameter. And you can go to the rating group setting. Remember I mentioned to you briefly, this is where you can define condition factor. And right now, in this example, I've actually put the entire girders in one single group, right? It's just a two-span structure. Let's say I only have one condition factor that applies to all, then you can actually work with the one group. If the different condition factor needs to be applied, span by span or girder by girder, you can actually create different structure groups over here. And right now, entire girders are in one single group. But if you want, you can actually specify the group for each order line or each span. So that way, when you define your rating group, you can reflect different condition factor about different part of the structure. Rating material here, same as the design portion. So basically, we are just giving you the flexibility of modifying the material strength for the rating checking or the design checking. And also, this is actually very important here, defining the rating case. So here, let's take a look at the interface. So here, we don't work with the load combination before, but for the rating, you will have to define the rating case over here. And for the service limit state, you will see that different loading type has the basic the factors predefined already. And for each loading type, what we are doing is which loading case belongs to this loading type, right? So DC, for the DC, self-weight, wet concrete weight, the formwork belongs to the component loading. And for the wearing load, I have, let's say I have the wearing surface load, so I can specify the two. And for the temperature, okay. If you have one, you can specify the two. And then you can define other user-defined loadings and manipulate the loading factor if you need. And here you can specify the live load factor for the rating. Since this is the service limit state, we have factor 1 for any type of vehicle. So the permit vehicle with 5 axles, permit vehicle with 7 axles, 9, 11, and 13. Depending on the number of the permit vehicle axle, ASTO specifies different vehicle factor. So, for the service limit state, it's just flat, one for all, so you don't have to worry about it much. But once you go into the strength limit state, you will see these factors updated for the strength limit state. And also, if your DOT requires the check with the adjustment vehicle also, you need to specify the factor for the adjustment vehicle. If it's not the case, just flat it at 0, so you can simply disregard this adjustment vehicle. And also here, you can specify if this is for the design rating check, or if it's legal or the permit rate level checking. So you can check the evaluation model too. Depending on the type of the vehicle, you can specify, since this is for the posting or for the legal vehicle, you can choose the legal load and permit load mode. If you have a design vehicle to rate, you can choose the design live load over here. And give the name and description and simply add that information, right? And for the service limit state, it's the same. You will be able to get the range of factors updated automatically. For each loading type, specify which load cases that you defined in the pre-processing belongs to each loading type, right? So specify the information. The loading factor for different vehicle, it's also here automatically, so you can simply choose the type of the vehicle and say OK in order to reflect the factor over here. Or it's open for free modifications in case you do not see what you need for the vehicle factor. And depending on the vehicle that you choose, you can, of course, for the strength limit state 2, choose the model, the evaluation live load model, either design type or the legal or the permit level. This is how you can define your rating inputs. And after you do, you will have to specify the position for the rating output and so on, similar to the design output. Just need to specify the location at which you want to produce the Excel report for. The summary Excel report will include literally the summary of every location. So you'll be able to get a summary table like this. And also you can get the specific page for the locations that you specified. Okay. Yeah, that's an overview of the design for the pre-stressed concrete composite. Yep, I've covered the material today. If you have any questions, feel free to submit it. However, due to the lack of time, I may not be able to get to all of it. Let me try to cover like a couple at least. Give me 1 second. For your information, the training recording will be published online, and you'll be able to receive, any registrant or the attendee will receive the follow-up email, and you will be able to find the link to the material, the recording, the Excel reports, and also the design guide manual, and also the summary slides that I used today, and also the model file. Okay. Yeah, I don't think I will have time to cover the questions, but I'll try. I'll address them and send it to the individuals accordingly. Thank you so much for your time. Our third webinar is about a steel plate girder bridge. Look forward to the invitations. And if you have any questions about the training or the promotions for the current Midas users, feel free to let me know too. Have an awesome day, everyone. Have a great long weekend. I'm excited too. Bye-bye.